Machine language is the foundation for most AI solutions.
Imagine you're creating a software system to monitor credit card transactions and detect unusual usage patterns that might indicate fraud. An application that tracks activity in an automated production line and identifies failures. Or a racing car telemetry system that uses sensors to proactively warn engineers about potential mechanical failures before they happen.
These kinds of scenarios can be addressed by using anomaly detection, a machine language based technique that analyzes data over time and identifies unusual changes.
Let's explore how anomaly detection might help in the racing car scenario. A race car drives past an instrument panel show telemetry values which vary over time. When an anomaly occurs, a warning is displayed and the car stops.
Sensors in the car collect telemetry such as the engine revolutions, brake temperature, and so on.
An anomaly detection model is trained to understand expected fluctuations in the telemetry measurements over time.
If a measurement occurs outside of the normal expected range, the model resorts an anomaly that can be used to allow the race engineer to call the driver for a pit stop to fix the issue before it forces retirement from the car.
In Microsoft Azure, the Anomaly Detector service provides an application programming interface API that developers can use to create anomaly detection solutions.
Yeah, understand the computer vision. Computer vision is an area of AI that deals with the visual processing. Let's explore some of the possibilities that computer vision brings.
The Seeing AI app is a great example of the power of computer vision, designed for the blind and low vision community. The Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects.
Computer vision models and capabilities. Most computer vision solutions are based on machine language models that can be applied to visual input from the cameras, videos, images. The following table describes common computer vision tasks.
Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle, the content, such as taxis, buses, cyclists, and so on.
Object detection machine language models are trained to classify individual objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle.
Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors.
You can create solutions that combine machine language models with an advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image.
Face detection is a specialized form of object detection that locates human faces in image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features.
Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs, storefronts, or to extract information from scanned documents such as letters, invoices, or forms.
Microsoft Azure provides the following cognitive services to help you create computer vision solutions. Computer vision. You can use this service to analyze images and videos and extraction, descriptions, tags, subjects, and text.
Computer vision. So custom vision. Use the service to train some custom image classification and object detection models using your own images.
Face. The face service enables you to build detection and facial recognition solutions.
Form recognizer. Use the service to extract information from the scanned forms or invoices.
Understanding natural language processing. Natural language processing (NLP) is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources.
Interpret the spoken language and synthesize speech responses.
Automatically translate spoken or written phrases between languages.
Interpret commands and determine appropriate actions.
For example, Starship Commander is a virtual reality game from Human Interact that takes place in a science fiction world. The game uses natural language processing to enable players to control the narrative and interact with in-game characters and Starship systems.
Natural language processing in Microsoft Azure. In Microsoft Azure, you can use the following cognitive services to build natural language processing solutions. Language. Use this service to access features for understanding and analyzing text, training language models that can understand spoken or text-based commands, and building intelligent applications.
Translator. Use this service to translate text between more than 60 languages.
Speech. Use this service to recognize and synthesize speech and translate spoken languages.
Azure Bot. This service provides a platform for conversational AI, the capability of a software agent to participate in a conversation. Developers can use this bot framework to create a bot and manage it with the Azure Bot service, integrating backend services like language and connecting to channels for web chat, email, Microsoft Teams, and others.
Understand knowledge mining. Knowledge mining is the term used to describe solutions that involve extracting information from large volumes of often unstructured data to create a searchable knowledge store.
Knowledgeable mining in Microsoft Azure. One of these knowledge mining solutions is Azure Cognitive Search, a private enterprise search solution that has tools for building indexes. The indexes can then be used for internally only use or to enable searchable content on public-facing internet assets.
Azure Cognitive Search can utilize and built-in AI capabilities of Azure Cognitive Services such as an image processing, context extraction, and natural language processing to perform knowledge mining of documents. The product's AI capabilities make it possible to index previously unsearchable documents and to extract and surface insights from large amounts of data quickly.
Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. The following table shows some of the potential challenges and risks facing an AI application developer. Bias can affect results. A loan approval model discriminates by gender due to bias in the data which it was trained.
Errors may cause harm. An autonomous vehicle experiences a system failure and causes a collision.
Data could be exposed. A medical diagnostic bot is trained using sensitive patient data which is stored insecurely.
Solutions may not work well for everyone. A home automation assistant provides no area output for visually impaired persons or users.
Users must trust a complex system. An AI-based financial tool makes investment recommendations. What are they based on?
Who is liable for AI-driven decisions? An innocent person is convicted of a crime based on evidence from a facial recognition. Who is responsible for this?
Understand responsible AI. At Microsoft, AI software development is guided by a set of 6 principles designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences.
The number one is fairness. AI systems should treat all people fairly. For example, suppose you create a machine language model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. The bias could be based on a gender, ethnicity, or other factors that result in unfair advantage or disadvantage to a specific group of applications.
Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model.
Another example is Microsoft's implementation of responsible AI with the face service, which retires facial recognition capabilities that can be used to try to infer emotional states and identify attributes. These capabilities, or if misused, can subject people to stereotyping, discrimination of unfair, denial of services.